Okay, a tennis ball of mass 0.16 kg moving 35 meters per second is struck by a racket and travels away from the racket in the opposite direction to that of its approach. What is the momentum of the ball before being struck? This is 4H is a basic question. So basically just P equals to mv, okay, equals to 0.16 times 35. So 0.16 times 35, let me just get a calculator. You'll get 5.6 Newton seconds. Okay, part B. So the figure below shows the force which acts on the ball during its period of contact. Calculate the impulse applied to the ball. Now, impulse is just the area under the force time graph. Okay, so this is easy, equals area under force time graph. So the area will just be, okay, let's read. So this is 0.1. Let's zoom in a little. This is 0.1 seconds, so this is around 0.12. It's 0.04. Okay, 0.04, 6, 7, 8, 9, 10. Yep. So 0.04. So the area will just be half base times height, half 0.12 minus 0.04 times height, which is 280. Okay. So one thing to take note is all this SI unit stuff. We see that here is still seconds, it's not milliseconds, so we don't need to bother about that. We also see that this is Newton, so we also don't need to add in other prefix here. Okay. So from here, basically just need to calculate 0.12 minus 0.04, you get 0.08 divided by 2 times 280, you get 11.2 Newton seconds. Okay, so next we need to find the average force. Okay, average force is just the change in momentum over the change in time. And the change in momentum is the impulse, is 11.2. Change in time, 0.12 minus 0.04. Okay, so what we calculated earlier, which is T2 minus T1, that's the change in time. So divide by 0.08, you'll get average of 140 newtons. Part 3, the speed of the ball after it loses contact with the racket. After it loses contact. So it strikes and it goes off in the opposite direction. So let's say we take rightwards positive. So initially it's 5.6 Newton seconds. Pi equals 5.6. Impulse is 11.2. Okay, there's a change in momentum, but it must be leftwards, equals 11.2 Newton seconds. So the final momentum will still be 5.6 Newton seconds. Okay, so it bounces, it hits at 35, it will also be the final speed is 5.6 divided by 0.16, you will still get 35 meters per second, but this time the velocity is leftward, so it bounces off. Okay, so that is the answer. Okay, next one. Part C. Sketch a graph of the applied force with time for the period of contact with the racket. Okay, if the strings have loosened. So if the strings have loosened, okay, it probably will take a longer time. So let's sketch the axis first. Okay, let's sketch this. Okay, and then here. So this C part one, let's do it here. This is the time. This is the force. Okay, so by if you have played with a badminton racket, okay, when the strings are not so tight, the amount of the maximum force will actually be lower. The time of contact will also be longer because it takes longer for the strings to stretch. Okay, so it'll probably be shorter. Okay, are they supposed to? Let me see. For the period of time, yeah. So it should be still the same. I believe it should be still the same. Okay, for the period of contact, but it will be lesser force here. The maximum force will be lower. Okay, so C part one, not very clear what the question wants. Okay, but for part two, max force is lower. Okay, and T2 minus T1, the time interval is longer. So they tell you that the final speed remains the same. That means that the area will be the same because the impulse is the same. Okay. For C part one, I think it's not very clear, so I'm not very sure whether this is correct. Okay, the question does just write sketch, but it doesn't really give much more details of what are needed. Okay, so it should be generally the same. Okay, D. Why explain why it is good practice to move your hands back when catching a ball, okay, rather than keeping your hands still. So what happens is that when you move the hands back, right, it takes longer for it to come to rest. Okay, so moving the hands back, let me just expand this. Moving the hands back increases the length of time for the ball to come to rest. It's not like instantly it comes to rest. It takes some time, increases the length of time to come to rest. Now, as for A level questions, we need to talk about changes in momentum. Okay, so the change or the decrease, okay, it's the same thing. The change in momentum is the same since the ball still comes to rest. So the length of time increases. So therefore, the by Newton's second law, the average force on the hand decreases. Okay, because delta P over delta T. This delta T, this delta P. Delta P has no change, but delta T increase, so average force decreases. So that's why it's good practice. This reduces the why because they need to explain why it's good practice, so we need to have a conclusion here. This reduces the chances of injury to the hand. Okay,